So I actually went on vacation and came back, and that same weekend I had to choose a university, and I just had to choose something. So I chose aerospace engineering, thinking that I would only do that for a year. But already after 3 months, I decided, okay, I'm not going to be a surgeon. I'm going to stay in aerospace engineering. I already started seeing that it was only structural. There are more domains involved when you create something. I was always wondering, why at the start of the project we would get a pressure distribution, for instance, coming out of a wind tunnel, and the coming 2 to 3 years, we would work with that same pressure distribution. I already felt like if you have a wing moving or a tail moving, that would influence the
Yeah.
flow around it, right? So I was already thinking, we need to expand. Mind you, Excel is a stress tool, right? I heard a Boeing executive saying once that still the biggest tool used in aerospace engineering is a mouse and Excel. What the digital twin was meant for back then, they didn't achieve. But what they did achieve was locate potential threats during the full-scale testing campaign. Because at some point they drove the simulation up to a certain point where they saw issues not so much with the airframe, but with the testing structure. If we have to go to ultimate for this load case, the testing structure will fail. The customer was calling and saying, yeah, I have an aircraft on ground. Can I fly my plane back to where I can do the maintenance? So in one weekend, we had to check the structure for the repair it had to undergo, or did it need a repair or not?
Yeah.
So I was hunting on the folder system, what is my most current model compared to the structure
Yeah.
really being there on ground on
Yeah.
some
Yeah.
desolated airfield. I was like, never again. I want full traceability of
Yeah.
everything. The coming 2 to 3 years, you cannot do without an SDM system, because
Yeah.
traceability is getting more and more important,
Yeah.
if not only for your company, it will be from the regulations that authorities are going to demand that they can see the data with full traceability to
Yeah. Yeah.
where everything is coming from. You're doing a great job with the Apex training, and all the guys we have in the company. The first thing they do is that Apex training. The new ACMS within MSC Nostran is in my opinion world leading, and that is because MSC Nostran has a background in that field.
Yeah.
No new adopter can come in with that legacy knowledge.
Yeah.
They will do the math. They will probably know how to program it and make it as efficient, but they don't have the skill set or the knowledge that the support from Hexagon, but also
Yeah.
within In Summa, can deliver to a company.
Noël Bijl is an experienced FEA engineer and software support specialist with over 15 years' experience in engineering simulation. Based in the Netherlands, Noël spent the majority of his aerospace engineering career with Fokker Aerostructures. He currently works as a simulation technical manager at In Summa, a Hexagon partner and reseller of the design and engineering CAE software portfolio. Focused on software deployment and training at In Summa, Noël's experience helps companies in the Benelux region develop the products of tomorrow. In this conversation, we spoke about Noël's early academic conversion from future surgeon to aerospace engineer, his work in aero-focused structural development, and as a driver in the use of large-scale FEA, the need for better traceability in simulation data management. Cool, right, thank you, Noël. We're good to go.
Yeah,
I'm in the UK. You're based in the Netherlands.
In the Netherlands, and I'm not going to pronounce the name where my office is. It's close to Breda. That's easier. So it's in Brabant.
Right.
It's typically a rural area, but we're on an industry park, and in a very nice office, because in my view, your surroundings should support the energy you have to bring to the job. So at In Summa, we try to deliver that to every engineer working here.
So how far are you from Amsterdam?
From Amsterdam, it's about a 15-minute to an hour drive.
Okay.
So
Okay.
that for Dutch understanding, that's quite a drive. But I'm guessing in other countries, a 50-minute drive would be a commute, a one-way commute to your working place. But in Holland, going from north to south, we cover not just the Netherlands, but also Belgium and Luxembourg. Then it would take you about 3 hours, to drive from the upper north to the lower south of the Netherlands.
Okay.
I just did a Apex course actually at Goodyear in Luxembourg. They're doing quite some nice stuff. They're a tire manufacturer, obviously, but they get their rims supplied by their customers. And what they want to do is modal analysis. So look at the vibration, and in the end, also the sound coming from those wheels and tires. So and they're very happy with Apex and the hex meshing capability.
Yeah. Cool.
So, yeah.
Okay. Right. Thank you. Probably step back a little bit and if you could perhaps give a brief introduction of yourself.
Yeah.
What you do, and then maybe a reasonably short summary of how you've got to where you are now.
Yeah. Well, it was actually not so straightforward for me becoming an engineer. I was basically not entitled, but my whole idea was to become a surgeon or a doctor.
Okay.
And in the Netherlands, you do your exams, and then when you have a certain grade, you come into a certain group, because it's a numerous fixes. So not everybody gets into a medical university. You have to be on a certain grade. And I didn't end up in Group A. And Group A just basically means you get in. Group B means that 10% of that group gets in, and the rest gets in a year later. Okay. So I actually came home and I said, Dad, I'm in Group B, so I have to wait for a year to become a surgeon. And he actually said then, okay, you either work or you do something else. I looked at a year of traveling, but he wasn't down with that.
This is your father you're talking about now.
That was my father saying that you either work or you do another study for 1 year, because doing nothing for 1 year, he didn't agree with that. So I actually went on vacation and came back, and that same weekend I had to choose a university. And a friend of mine actually said, shall we go to the technical university to check out the possibilities over there in Delft? And he was really thinking of doing aerospace engineering, and I just had to choose something. So I chose aerospace engineering, thinking that I would only do that for a year. But already after 3 months, I decided, okay, I'm not going to be a surgeon. I'm going to stay in aerospace engineering. So I did my bachelor in Delft, the technical university, and then I did my master. I did a dual chair. I did materials engineering and structural analysis, the combination of the two. And back then at Fokker, but also at Airbus, they were looking at a new piece of material, glare, which is a glass fiber reinforced aluminium stack, so to say.
I remember.
Mainly for fatigue purposes. But already back then, due to my dual chair, materials and structural analysis, it was like, Fokker, an aerospace supplier in the Netherlands, was thinking about a finite element model to predict, the behavior of glare, because glare is actually stacked aluminium layers with glass fiber layers, and the glass fiber would bridge where the aluminium sheets would end. And due to all kinds of reasons, they wanted it to behave like aluminium. And that had to do with the repairs, right? Composite repairs are way more difficult than aluminium repairs. So what the inventor of glare promised to the industry was that glare would behave like aluminium, also in repairs. But to do that, they wanted to see what the behavior is of glare. And to that end, they've asked me as a graduation project to create a finite element model of a splice. And splice is the area in glare where the aluminium sheets end, and the glass fiber, bridge the gaps.
Yeah.
And well, actually, in my talk before that, presenting the assignment, there was a guy in the audience who said, 3 people tried, just give up and choose something else because you're not gonna do it. And I'm a guy, when you tell me that, I'm even more driven to get it work. And okay, it took a bit longer than usually. It's 9 months, the graduation period. It took me 10 months actually. But for the modulus and for the yield and also for rupture, I was able to get a finite element model going and a material model going that could predict within 1% the modulus, around 2% the yield of the material, and within 5% the rupture. And back then I was a young engineer, so I was like, yeah, this is normal, right? With simulation, you can simulate everything. I still remember the first line of MSc software back then, and that was simulating reality. And I was like, yeah, I'm simulating reality because I had heaps of test results. I was comparing my finite elements models. Back then I didn't know it was verification and validation. I was comparing it, and I was just seeing good results. And that's actually how I entered also aerospace industry. I was already.
Can I? Sorry to cut across you. What simulation tools were you using for that lap model or that joint?
Yeah, the splice.
Yeah, the splice.
I actually was already infused with the idea of first finding the right tool for the job. So actually, the first 2 months, I set up a benchmark. And what I did, I compared stress check, I compared Nastran, and I compared Abacus, and I had a few KPIs, key performance indicators, to give me a score, what tool to use for the rest for the rest of my graduation period. Well, stress check is a polynomial finite element solver, so you don't need a lot of elements. Just the grade of the element is increased to give more flexibility of the element and a better representation of the stress or the strain. But for yield, it didn't act or give me the results that I was hoping for. Actually, Nastran and Abacus at that point, because you need to go nonlinear because of the rotations and well, actually geometric nonlinearities in that model, but also the material nonlinearities because of doing yield and rupture. Both Nastran and Abacus were actually at the same point. So I was in a bit of a jam because my benchmark ended up with identical scores for Abacus and Nastran back then. So I had to go think of another score or a decision maker, another KPI. And in the end, back then, Abacus was more flexible in parameterizing your finite element model. And I had to go through so many combinations of glare, so thickness of the aluminium and the width of the gap and the crossing of the glass fiber layers. And well, there are all kinds of dimensions in a splice, in a gap in glare that back then Abacus was way more flexible in parameterizing. So in the end, and Fokker actually wasn't happy with that because they are a big Nastran user, MSc Nastran user. I came in the company and I said, I'm going to do my graduation in Abacus. We're like, wow, but we don't have Abacus. But in the end, they agreed because I showed them the benchmark, I showed them the results, and they were fine with that. And actually, they took also Abacus on into the company because of that. And yeah, those were actually the tools I was using back then. Mainly just on the structural side. And the results were very convincing. And yeah, they're used within in Fokker still. And basically on a small level, that is already a digital twin. Digital twinning is something that I'm very interested in. We still have to make big steps, but all the applications are getting into a format that we can make it more digital twin and talking to each other even better. But actually, at Fokker, I came in when I graduated. I was already working as a contractor back then, because at an internship, I'm very interested in instability, so dynamic instability and also instability, also called buckling, right? Buckling of panels. And back then, a lot of composite structures, integrally stiffened composite structures, were used at Fokker for a helicopter, the NH90.
Yeah.
My internship at NH90 was to investigate the buckling properties of incorporating boundary conditions, right? Because back then, we were at Fokker, they were investigating if you would have a fixed boundary condition or a clamped boundary condition. They were seeing some odd results, and actually, it was not because you're constraining the rotations in a clamped situation. It was actually when you dive deeper into Nastran back then. I think they were using 2008 back then, Nastran version 2008. Mm-hmm. You get coupling you have the ABD matrix, and in a linear solution, in a linear buckling solution, only the A matrix is basically solved. So the coupling matrix, the D matrix, the coupling between tension and rotation, in a linear situation is not used. And because of the offset in a sandwich structure, you actually get coupling because you're not quasi-isotropic.
Gotcha.
Quasi-isotropic anymore.
So you're not probably taking account of the bending in the outer plane effects with the linear eigenbuckling. Yeah, gotcha.
So I actually demonstrated during my 3-month internship before I graduated already that from a methodology side they had to look different at doing instability, because back then they were doing instability just on a linear in a linear domain.
Gotcha.
Back then they realized that they had to go to non-linear.
So with your academic work, and then you're moving to the aerospace industry with Fokker and the various programs that you're looking at, you're already in a mindset to be. You mentioned verification and validation, but you're already in a mindset where you're trying to use the best analytical methods, whether they're FEA or some other means, to really capture physical behavior, to then drive the design performance. Because I've seen examples where legacy methods have so much conservatism built into them, you end up with a heavy structure. So by tailoring these methods and these techniques, ultimately you end up with a better product. So I mean that's a great foundation, a great mindset to have. So you spent the time in the aerospace industry, and then you transitioned, or you stepped away into a software usage. Software reselling, vendor reseller type of situation. So what was your motivation, or what was your reason to move away from a direct aerospace client into a reseller?
Multiple, to be honest. There were several reasons for me doing it. My time at Fokker was a really fortunate one, because I came in as a junior engineer, and already after 6 months, the patron key user at Fokker, they had key users for the application. The patron key user decided to leave the company, and for some reason, I don't know, for some reason they looked at me and they said, "Okay, how do you feel about taking on that role?" And I was really a computational guy, and I was like, yeah, of course, I like to see what you can do more with Patron and set out the routes. So already after 6 months, I became a key user. And next to that, I was very lucky to be always involved with new concepts. So the G650, the Gulfstream G650 business jet, I was involved from the start. JSF, I was involved from the start. So I was always working on new projects. So I liked it. What I liked a bit less was I already started seeing that it was only structural. And I felt, there are more domains involved when you create something. I was always wondering, why at the start of the project we would get a pressure distribution, for instance, coming out of a wind tunnel, and the coming 2 to 3 years we would work with that same pressure distribution. I already felt like if you have a wing moving or a tail moving, that would influence the flow around it, right? So I was already thinking, we need to expand. But due to those projects, in the end, I became a functional manager at Fokker Aerostructures, involved with all the stress tools. So not only simulation tools, but also, mind you, Excel is a stress tool, right? I heard, I think, a Boeing executive saying once that still the biggest tool used in aerospace engineering is a mouse and Excel. That was a wake-up call for me. But we also had in-house tools like fatigue procedures programmed in Fortran, and that all needed to be managed. I think from an engineering point of view, you sometimes don't see that when you create your own script, but maintaining that script for at least one project, and a project it takes about 3 to 5 years. There are bugs in, you will get support questions. And at Fokker, we started realizing that at some point you need a whole department to maintain all the tools. And then being a functional manager and seeing all the stress tools, but seeing them as islands, I was like, okay, yeah, I can maintain that, or see how we're going to integrate that. We had some people in the company having very good scripts and very good ideas of how to do that. But at some point also the market changed. I already said I had multiple reasons for switching from aerospace to the vendor side, so to say, to the reseller side. And that was at some point we didn't see any new projects coming in. And I was always on the good side of projects, being, on the conceptual side and starting off with setting out the structural points and thinking about what we're going to do on a simulation side. So I didn't feel myself evolving even more. At some point, next to being a functional manager, I was a specialist too at Fokker, and I think the highest you can get at Fokker was a specialist 3. But I felt a bit stopped in my development. And well, my luck continued because at some point I was called by the CEO of the company I work for now, and he was actually asking me if I knew anybody in my surrounding that would be interested to join his company. And I was really thinking, and all my friends were already working. Nobody was looking for a job. And actually, at the end of the talk, he said to me, "What about you?" And that planted a seed in my mind. And because I already knew In Summa, because they supply actually Mastran and Patran to Fokker in the Netherlands. So I already had contacts with them. And well, gradually I came to think, let's go to the vendor side. Let's go to the reseller side, especially with the thought of being able to integrate the tools more than I was capable of at Fokker. At one of the NAFEMS conferences, I had a talk with a chief engineer from Airbus actually doing the digital twin for the A350. I think from start to end, they had a digital twin running for the A350 up to the full-scale tests. And back then, actually, his conclusion was that what the digital twin was meant for back then, they didn't achieve. But what they did achieve was locate potential threats during the full-scale testing campaign. Because at some point, they drove the simulation up to a certain point where they saw issues, not so much with the airframe, but with the testing structure. Because they modeled the airframe and they modeled the testing structure. And at some point, they said, okay, if we have to go to ultimate for this load case, the testing structure will fail. And they actually looked at the testing structure and they were like, okay, now we see a serious flaw in the test rig. So they were able, with a delay of 3 months, unfortunately, they were able to upgrade the test rig to a situation where they could still do the alternate load test. Well,
Yeah.
in his opinion, that wasn't the definition of a digital twin, but it definitely helped them of not destroying their prototype, not destroying the test rig, with probably a delay of even more months than they were already facing. And I really felt like, with the integration I already saw going on outside what we were doing at Fokker, I was like, okay, I want to broaden my horizon at the vendor.
Mm.
That came about to me going to the vendor side and the reseller side.
Okay. So obviously there are a myriad of different simulation digital tools involved in the design of an aircraft structure, or an aircraft full stop.
Yeah.
So you could see all these different technologies panning out. So being in the reseller environment gives you more visibility across all of those different things. Yeah. Okay. I mean, we talked about this a little bit before we started recording. Given all of those different tool sets and the way that they work with companies, how do you see the simulation software market developing, changing?
Developing, changing is a very interesting word you're choosing, because some industries are prone to reluctantly changing, being very traditional, looking at legacy methods. So changing is sometimes a bigger effort, but developing, I think that a lot of vendors what I see at Hexagon, I'm closer to Hexagon, obviously, with being the MSC D&E branch in there.
Perhaps what just to cut across you there, now, for people that are watching, we should say that In Summa are a Hexagon partner in Benelux, and my company Evotech Hexagon partners in the UK. So we have a lot of synergies in terms of our business, but different geographies. So,
don't worry. And now it sometimes is a bit difficult explaining it to customers how it works, right? Because MSC is a well-known brand. It's a world brand, and it was taken over by Hexagon. So we had to go to our customers and saying, MSC Nastran is the right tool for you, and it's being sold by Hexagon. It's being created by Hexagon and being sold to you by In Summa. So I don't know if you encounter anytime that thing, but sometimes it needs some explaining. Being a reseller, how it works. But within the Netherlands and Belgium, Luxembourg is a somewhat smaller market, but within the Belgium and Netherlands market, In Summa is the exclusive reseller for MSC. So that gives us a good position as well. The naming starts to become more known, and also the relation In Summa versus Hexagon. But what I started off with Hexagon, right, is that I got closer to the vendor side because we're the reseller now, and I actually came acquainted with a lot of more possibilities of integration of simulation tools. Not only in the simulation tool itself, let's say Nastran, for instance, the combination with Apex. When Apex first came about, it had the Nastran solver inside. Well, it still has, and actually upgraded to full Nastran, which I really promote. So the integration of that already in a tool is very good. But what I also saw with, for instance, Sim Manager, is that you can link up not only your structural solver, but also your CFD solver and also your MBD solver in one location. One location is maybe a bad choice of words. It's more that in one environment. Let me put it like that. And you can cooperate across several sites, because what I also started seeing in the time I transitioned from aerospace to the reseller industry is that the creation or the manufacturing or the engineering got fragmented. Fokker didn't do anything. Well, didn't do some of the parts itself anymore. They would outsource the creation of for instance, an aileron to a smaller company. And then cooperating is very difficult, both on communication side, right? You email, or how do you get the parts across? The results files started getting bigger. So how do you move that across? Also in a secured way. So when I was at In Summa, I saw Sim Manager, basically an SDM tool. I was already aware of PLM tools.
So SDM, simulation data management.
Yeah, simulation data management. I was already looking at that at Fokker because we felt that we needed to move into that, in that world, and maybe only for storage, right? And legacy, because in an aerospace environment, you have the obligation to retain your stress reports, your FE models, basically all the data coming to a certain part for 20 to 30 years, the lifespan of an aircraft. Well, doing that on a file system, right, with a hard drives or whatever, the traceability is very difficult. Well, one example, if I may, we had an aircraft on ground situation once on a Friday. The customer was calling and saying, "Yeah, I have an aircraft on ground. Can I fly my plane back to where I can do the maintenance?" So in one weekend, we had to check the structure for the repair it had to undergo, or did it need a repair or not? So I was hunting on the folder system. What is my most current model? What is this model version compared to the structure really being there on ground on some desolated airfield? And I was like, never again. I want full traceability of everything. And SDM system is one of the things that you could use to trace and even link certain jobs or documents to a real part.
So you've got that very well controlled digital thread of exactly what that physical, what inputs went into that physical structure to say that aircraft can fly or no, it can't fly.
Yes.
Yeah. Okay. That's massive, isn't it? Massive.
Yeah, it is. It is, and I actually see the market. Well, from our view, both aerospace. We get requests from aerospace companies in the Netherlands for SDM systems. But we already see it at other companies employing it. So it's. I think it's going to be a driver for the next coming years. Either being driven by regulations, because I read some reports from Brussels that not only on the PLM side, they have to be product lifecycle management, be able to present, the traceability and legacy in a manner, but the full stress results and how did you come about to this result, to this margin of safety, and to do that on a folder system, on a laptop or on a huge drive or whatever, you're not going to make it.
It's a big deal, isn't it?
Being involved with creating.
I mean, we talked very briefly again before we hit record about some of the trends that people talk about. AI, machine learning, cloud solving, HPC, meshless solutions, all this kind of stuff. But if you look at that growth of digital knowledge, you need a controlled environment to manage that knowledge, don't you? To manage that data. And if you don't have that, I mean, people talk about AI as a black box. If you don't have that control, all of your data is a black box, isn't it? Your file structure, your emails. Did he say this? Did he say that? I can't remember. That is a massive rabbit hole that people can get stuck down, isn't it?
Well, especially on AI, and when you follow it a bit, which I do. You already see a bit of a transition, I won't say trust, but understand AI. So the algorithms behind it, the mathematics behind it. Now, the next question of people is, okay, but the quality of the data, right? That's the next step. where do I get my data from?
Yeah.
Isn't it polluted with strange results, for instance, or strange inputs affecting my output? But if you don't know where your data comes from, and that's for AI, but for a simple stress report, if you don't know the original geometry that you've based your part on, and mind you, this happens daily. The stress engineers look at a part, and it's very difficult for them which version in PLM their part is based on, that they're working on. And what I've seen at several companies, because SDM has been around for quite some time already. I think 22 years. SDM, our tool, Sim Manager, or Hexagon tool, Sim Manager, has been around for 22 years. It's becoming more user-friendly by the day. We have bigger companies like Airbus employing it, BMW employing it, Embraer, which I found a very inspirational story when I saw it at an AFEMS World Conference. I was like, yeah, this is the way to introduce SDM into your company, because it needs a paradigm shift at the stress engineers, but also at the managers at companies. With PLM, it's fully accepted that you have a department of IT guys or guys with scripting capabilities,
data management skills.
Yes, managing your PLM. But for SDM, you see a lot of people saying, okay, what does it do out of the box? Well, SDM cannot work out of the box. Solution data management should represent what you're doing in your company. It is so customizable that first you need to have a vision yourself as a company, as an industry. You need to have a vision yourself, how you want to deal with the several pieces of data that you are using, and then we can set up the system for you. Or so it behaves like out of the box solution. But in my view, the coming 2 to 3 years, you cannot do without an SDM system, because traceability is getting more and more important. If not only for your company, it will be from the regulations that authorities are going to demand that they can see the data with full traceability to where everything is coming from.
No, that makes complete sense. It's not really something I've obviously worked in environments where we have SDM to record data and processing and what have you, but in terms of technological shift in simulation, that's the biggest thing, isn't it? It's got to be the biggest thing.
Because when you mentioned AI and the other stuff, I really see it as helping. We have to be careful with it, but it helps, because I was early introduced in aerospace already with robust design. Back then I was a young engineer and I was like, okay, well, what is this? Until I realized, when you run an analysis, it's one result. That one result is based on an assumption of what your material properties are, an assumption of what your load is, an assumption of what your boundary condition is. Hardly ever you do any tweaks back then, right? Hardly ever you would do any tweaks to see how your results would change if you would change your material a bit. Well, a mentor I had within Fokker was very fond of robust design, and I actually think now with AI and the possibilities to do design of experiments using AI, robust design really comes into a feasible grasp. Back then, you had to do a lot of runs and do a lot of stochastics and check, you had to get the normal distribution and whatsoever. It would require a lot of scripting. Now, helped by SDM, because it's not only a storage system, it's also a process automation system. You could almost already, if you customize it correctly, on a Friday, you could hit the go button in your SDM system, and on Monday you can have a full robust design in your SDM system. So stuff like that is coming into grasp with the automation and the developments within simulation.
So it gives you a better understanding over more physics, more sensitivities to give you ultimately a better product again, you know. So
Yeah.
these are things that are going to be driving simulation-based companies or simulation-based development. Yeah, okay.
I think so. Yeah.
Yeah.
And with those huge possibilities, also with co-simulation between physical domains, right? I used to do multi-body dynamics and structural analysis sometimes on separate computers. And I always wondered why. Okay, but if I do this in MBD, this will definitely give us stress to an extension arm of a flap track, for instance. But you know, how do I get that into my structural simulation to really size that beam? And now with the integration of MBD with structural analysis, but even MBD structural analysis with CFD, I didn't give that example by chance. What we can do nowadays is have a flap extending on a wing with the flow completely going. So we have an MBD analysis coupled with a structural analysis, coupled with a CFD analysis already. And okay, the single engineer can do that, but you can also automate that and load that up in an SDM system. And you know, I see AI as supporting tool. I see other stuff as supporting tool. What I really see coming into more feasible grasp is digital twinning. Because of automation. I already mentioned the A350 example, right? What they did was they modeled the full test rig, they modeled the full airframe, but you can enter more stuff nowadays when you automate it. So what I really see developing, changing. Okay, that's industry based, but developing is that we can do more digital twinning and better the digital twinning.
Well, that leads me on to the last question that I wanted to talk about, and this is something that I live day by day. You know, we've talked about the incremental change in terms of incremental development in terms of methods and processes that companies are using, and we've also talked about the many different types of product in physics and what have you that can be used and how they can be coupled and this kind of stuff. So, well, and thirdly, you know, we're both involved with Hexagon as a company who really are at the cutting edge of simulation software development. You know, there's no two ways about that. You know, Nastran as a product is used in pretty much every aircraft certification program around the world. You know, I mean, I know there are, you know, new companies popping up and looking at different methods and looking at efficiencies and blah, blah, blah. But if you take a step back and see these tools are the standard for these industries, there are certain things like Apex, obviously, which I'm heavily involved with, which are coming in to assist with that workflow and assist with that development. And, you know, I talk to people all the time about the benefits of these new tools and what have you. But I find that I wouldn't say the majority, but in certain cases, there's a reluctance for people to consider new approaches, new tools, new methods, because they're so ingrained in the data structures, the tools, the skill set of the people using those tools. You know, so as a reseller or as a software vendor, what do you see are some of the main challenges in terms of developing new business, either with new companies, new industries even, or with existing companies to adopt new software tools and new methods? You know, how do you see that landscape looking for you in Benelux?
Well, from a business point of view, simulation market in the Benelux is actually pretty good. And I do see it developing. The last year, one of the first requests I got this year was for sim manager at a university in Groningen, because what they wanted to do is cooperate with more companies in the north on skin models, right?
Yeah.
Because what they do is they look at shaving caps. Well, I didn't shave today, but they design shaving caps. But what they want to extend their domain with is how the skin behaves when a shaving cap is put on. Well, the skin is modeled by the university, but the actual jobs are set up. The simulations are done by Philips, a company in the north. And to cooperate, they already saw that SDM simulation management is a good tool. So I see a lot of development there. Companies are already adopting it and seeing the benefits. For the existing software, I think the challenges are that when you're in discussion with somebody on the table, understand what his drivers are and what his pain is. When I'm talking to a stress engineer, he will have a different pain than when I'm talking to his lead and or when I'm talking to their technical manager.
Yeah.
They operate, their drivers are in different domains. So the challenge, not only for us, but I think for every vendor, is to realize that when you're sitting with somebody around the table, is that you're talking the correct language. When I'm speaking to a stress engineer, or when one of my consultants is speaking to a stress engineer, show him the value of a tool being brought in. What does it give him? More efficiency, less trouble coming to a solution. I had a question once from a guy from the TU Delft saying, "Yeah, I have a nonlinear run. Well, I want to run so many jobs. Can we optimize this so that it will run within a certain time period?"
Yeah.
Then you're talking about that. But his supervisor might be saying, "Okay, can we limit the amount of tokens? Because I also have other graduate students trying to use the token."
Yeah.
And then you're saying, "Okay, but if I'm limiting the amount that he's using the licenses or tokens, then the other guys will have more tokens as well." So the challenging part is to realize on what level you're talking.
Yeah.
From a technological point of view, you already pointed out what I see with the Nostrum development and also the Apex developments, but also with Mark and other tools, is that from a technological level, we are there, and we are keeping up. Well, not only keeping up, I think on certain levels with ACMS, for instance, within MSc Nostrum, I don't think a lot of users will realize, but the new ACMS within MSc Nostrum is in my opinion world leading, and that is because MSc Nostrum has a background in that field. No new adopter can come in with that legacy knowledge. They will do the math, they will probably know how to program it and make it maybe even as efficient, but they don't have the skill set or the knowledge that the support from Hexagon, but also within In Summa, can deliver to a company. So the challenge is to sometimes convince, next to who are you talking to in the company, sometimes convince that the tool is not the only thing you're buying. You're also buying the support behind it. Right? And I know YouTube or Google can go a long way, but talking to a physical person, having experienced the same issue you are experiencing while you're doing it, is way more valuable than that. So the challenge in that is, convincing new customers that the support side of it is also very important. And
so bigger picture, it's not just a list of new features or a list of efficiency gains or that kind of stuff. It's what's there to support the product in terms of software development, new releases, training, and the people who know the stuff and convey that information, whether it's a sort of semi-consultative type role or whether it's training or whatever. But those things are massively important, aren't they?
and I know from your end, right? You're doing a great job with the Apex trainings, and all the guys we have in the company. The first thing they do is actually that Apex training. I did it myself, and I think physical trainings, but also this training, right? Don't get me wrong. It's a very good training, but we see a lot of companies coming back to the thought of everybody can do an online training. We had the learning center, right?
Yeah.
If you have tokens from MSC, you can go into the learning center. You can click through the slides. You can do all the demos. You can do all the workshops. But in my view, it still doesn't compare to an actual training. And when you buy the software with us from Hexagon, and I know that's the case for you as well, we can provide a physical training either on site here at the company. We also do virtual, but I always say it's not my preferred way to do that. And the last training I gave was at Goodyear in Luxembourg, and we got very good comments on that. It takes one day, and you really have the trainer there giving you direct input of what you're doing, and it was very well received as other trainings we do. So yeah, in a virtual world and in home working that we do right after the Corona period, I do see a tendency to go back to trainings, customized though, right? So the standard training that we would have in the booklets, so the Nastran 101 or the Mark 101 trainings. Okay, we still do them, but we see a lot of customers saying, okay, yeah, I like to be introduced to Nastran or Mark, but I have this model. Could you do the training on that model? We supply that as well. So I think that is not only a challenge, but it is also a business driver for us. We see it with a lot of customers that actually like the support side of In Summa, but of Hexagon in general. I still like the support that I am also getting, right? Because I'm not knowledgeable across the board. I also have to ask my questions, and I know there is a very good team at Hexagon that will answer my questions. Sometimes in direct contact, sometimes through an email. Depends on the availability, but I think support is very important and can be a business driver.
Absolutely. Well, we're fortunate to be in a position where we can work with a progressive company like Hexagon, and in such an evolving and dynamic industry, aerospace, and all of the other stuff that we do. Yeah. Okay. So
100%, right. And what they're doing, for instance, on the manufacturing side as well, they're integrating, metrology, because Hexagon is actually known for metrology. It's a huge metrology company doing measurements with laser scanners, 3D scanners, and what have you. Now with the design and engineering branch they have inside, they can close the gap between coming from product to testing to updating that product, because in your test you're seeing something that you didn't expect. You can close the loop. We have had European projects where Hexagon was involved, for instance, closing the gap for AM. AM is a big thing nowadays, additive manufacturing. Well, we have a simulation tool for that, incorporating the heat and the heat flux and what have you, the compensation, to pre-compensate your part so it would actually roll out of your printer in a more or less good way. What Hexagon did in a European project was link that also with the compensation possibilities they have in their scanners. So you would do the simulation, you would go to the actual printer, from the printer you would scan the 3D part, and that would go back into the simulation. I know that I think it was called the Compass project. They realized 98% accuracy of an additive manufactured part with that process flow. Well, I think for industry that is amazing, because additive manufacturing, how flexible it is, it's also very expensive, especially when you're doing titanium parts. I think here on the back I have a few parts that are very small. They go into gas turbines, but it is amazing how much you have to pay for such a small part, and that is because all the engineering that goes in, the deformations you have, the stress, the residual stresses that are still in the parts. And nowadays with the simulation tools, you can get way better parts and way more accurate parts than 2 or 3 years ago. So
the world is changing. The world is changing.
Hexagon is a big driver on that manufacturing intelligence.
Yeah, good stuff.
Yeah.
Cool. Okay, Noel, thank you. Well, we've covered a lot of stuff there. Really interesting. Yeah, a lot of topics. So I'm sure people
I can talk for hours about this. I really like the simulation world, and especially the closer link it gets to reality now. I think I mentioned it already today that simulating reality is something that stuck in my mind when I saw it on a brochure of MSc on several aspects, right? Because we're still simulating reality. We're not.
We're not there.
It's not reality.
We're never gonna be there, but we're just getting closer, aren't we?
I also teach courses at universities, and one of the first things I did, because I did not get that in my university back then, is giving them the realization that it's still a discretization of reality. It's not reality that you're putting in the laptop. It's a discretization of reality. Because when I exited university, I was that cocky that I think I actually said that I could simulate everything and predict everything. Well, the first actual full-scale test I had with a post-buckled panel in an upper skin, it popped in the wrong bay. I said, no, it's not supposed to buckle there. It's supposed to buckle there because I predicted in my simulation model that it would buckle there. So why is it buckling there? I was young. I understand now how that world works, but we're getting to a level that we can better predict, have a higher predictive capability, and it's a very interesting, still a very interesting world.
Yeah, absolutely. Good stuff, Noel. Thank you. I think that's a good point to end our conversation.
Thank you it was so great. It was great talking to you, Steph, and I really liked the series. You had some very interesting. You had some very interesting people already, and I already said it. When I look at the people you're having and you already had, I'm really honored to that you asked me, and I hope I can contribute to this. And it's we're gonna stay in contact anyway.
No, that's great. That's great, Noel. Thank you.
It was great talking to you.
Thank you.